So a utility line runs underground through Shane's rectangular backyard. Shane is not allowed to dig within 3 feet of the utility line. The diagram below shows the dimensions of Shane's backyard in feet. The dashed line represents the utility line. So basically, they're telling you this is the utility line, and he cannot dig into those parts. So what I'm going to do is I'm going to shade in what I could dig into. So if I could shade into this, that I could dig into that, right? I could dig into this too. So I need, says what is the area in square feet of the part of the backyard in which Shane is allowed to dig? So the only thing I cannot dig is those 2 sections, right? So how would I find the area of the shaded part? What would I need to do to find the area of the shaded part? There's several ways you could do this. So what would be the area of the whole thing? What would I need to multiply to find the area of the whole thing? Yeah, A equals base times height, which is 22 times 17. So let's find that area. So 7 times 2, 7 times 2 plus 1, add a 0, 2 and 2. So that's 374. So that is the area of the whole thing. But can I dig in all of it? No, what can I not dig into?
Don't you just subtract 6?
Why would I subtract 6,
Wait, no,
Jesse?
not 6. Ah. Wait, so what do we have to do?
So the red part is the part we cannot dig, right?
Right.
Okay, so then what do I need to do in order to
Find the area.
find the area of that now? So A equals, so what's the base?
6.
6. And what's the height?
17.
So 17. So let's go ahead and do that math. So 17 times 6, that's 42. That's 102. Okay, so now what do I need to do in order to find, subtract it? So now I'm going to go ahead and subtract it. So it's 374 minus 102. So that's 2, 7, and 2. So my answer is 272 square feet. Okay, so that's basically what you do. When they're giving you information like this and tell you this is the whole thing, but we cannot use this part, then make sure you're shading it in and looking to see what is it that you need. So in this case, 272 is all the gray area, in other words. Okay, now there's another way you could have done this too. And it would have been a lot easier if we started with that. And that is, if you see this is 22 and 17, right? Out of the 22, how much can I not dig into? 6. So if I did 22 minus 6, that's going to give us 14. And if I did 14 times 17, that would give us 272. So it's same thing. And the reason it's that you could do it with this one is because it's sharing the height. It's sharing the height and the base. So make sure either way works as long as you are subtracting it in one way or another.
22 minus 6 is...
Yeah. If you look at this part and you have your handout with you, it's asking you to find the area of this shape. So it doesn't have dimensions. It doesn't have dimensions, so that means you would need to measure it. Now you are measuring in centimeters, and you have the tools to measure each of those shapes. And what tool do you have on your desk that you could use?
That's going to be hard.
The reference chart. Now, guys, I know it's taped to your desk. So, because it is in a sleeve, you could just take it out, use it to measure it, and then put it back in. So that's basically what you're doing, and that's what your assignment's gonna be. Now, that's the first step, finding the area of the whole shape, and then I'll give you the second step, because there's another step that you need to do. So this is your assignment. You need to measure and find the area of each section of that composite figure. Now, it has a line for you to measure, so all you have to do is just measure. And remember, what dimensions do you need for rectangles? Base times height, right? And remember, what are base and height? How are you gonna look for them? Are you gonna look for them that they're parallel? No. Are you gonna look for them this way that they're parallel? No. You have to look at them where they are perpendicular, which means they create a right angle. So your base and height creates a right angle. Make sure you're measuring the correct sides. Any questions before you start?
The squares on the side, we just measured.
Say it again?
We just measured through the squares on the side.
Yeah, you could measure the squares as long as your
No, like-
base.
How they're blocking this, can we measure like all the way
You
down?
could do however you feel like doing it. Any questions?
Can we use partners?
No, you could do it on your own. I want to see what you understand.
Okay.
Okay, guys, so who could tell me what the dimensions are? Because most of you do have the same thing. So this one up here would be what?
7.5.
7.5. How about here right there? 3.5. Okay, so what is this one? Okay, so then this one here would be what? 3.5, right? How about this one? 3.5. How about this one? How about this one? How about this one? This one?
7.5.
So then what do you think this one's gonna be?
3.5.
And this one? So basically, you could kind of tell there's a pattern on the measurements, right? Okay. So go ahead and find out each area. Each area, especially those that are the same, because if you find the area of one of them, right, you could find the area of the rest of them. So go ahead and do that. Okay, so what would be the area of the rectangle? Okay, so what's the area of the rectangle? 26 and 25. So that means all of them is 26 and 25. So what would be the area of the square? Yes.
30.5. I meant 30.
12 and 25. 12 and 25. Okay, so what would you need to do in order to find out the area of the whole thing? Add them all up. So if you add them all up, so I'm just going to do 26.25 times 4. So that's going to be 0, 0, 5, and 10. So that means for this area right here, all of this would be 105 square centimeters, right? Okay, so how about the area of the 3.5?
25.
So it'll be 12.25 times 2, which is
3 times 5.
24.5. Okay, and that is this area. So in order to find the area of the whole thing, I would need to do what? Add them up. So I'm going to go ahead and add 105. Oops. 105 plus 24.5. Remember your decimal. So that's going to be 5921. So the total area of this composite figure is 129 and 50 square centimeters. Okay. Now, if you read this corner up here, if you actually read this, it's asking you, says the net of a rectangular prism. So basically, they're telling me that this becomes a rectangular prism. So why do you think it becomes a rectangular prism? So I need you to cut this shape. So you're going to cut all around it and create a rectangular prism. So cut around it and create. Okay, so guys, all these rectangles and the two squares becomes a rectangular prism. And remember, rectangular prisms are 3D shapes. So if I were to draw it as a 3D shape, then this is what it would look like.
Yeah, we already know.
Wait, that's wrong.
What the what? What
This is supposed to be there. Okay, so basically, this is your 3D shape. And if you notice the dimensions, this is going to be 3.5, right? 3.5. This is 3.5. And this is 3.5. And that was 7.5. So if you notice, they are creating the rectangles that you measured when it was a flat surface. When it was a flat surface. Those are all 7.5. Now, this is called a rectangular prism because the base, you look at the base is a rectangle. Okay, those are the bases. So whenever you're doing any 3D shape, you will have to find the area of the whole thing. It's easier to find it when you have the three-dimensional shape flat like we had it in this case. Now it's easier to find that area. Well, when you're doing the area of a 3D shape of all around, that is called surface area. So this is not just area, it's surface area because it measures everything that's around that 3D shape. So starting tomorrow, we're going to go ahead and see this, make sure that you're understanding that one flat composite figure becomes one 3D shape. So we're going to be doing that tomorrow. Today was the rectangular prism, which you did last year. We're going to include triangular prism. We're going to include square pyramids and triangular pyramids. So, and we'll talk about the bases and all that.